Hey everybody, Dr. A here, and in this video we're going to be providing some background information on truss systems. So let's go ahead and get started. What exactly is a truss system? Well, a truss is a type of structural system that's made of slender members joined at their ends by smooth pins. Now, you can have two-dimensional or three-dimensional trusses. A 2D truss is called a planar truss, and a 3D truss is called a space truss. So let's go ahead and visualize these. Where do we see these? Well, we often see planar trusses as the structural support system of building roofs or of bridge decks, whereas we see 3D trusses or space trusses more as like power towers or transmission towers. They kind of have this three-dimensional lattice structure to them. Okay, so let's draw some examples. Let's say 2D or planar truss. Okay, so if we look at some options here, we could have a simple 3-bar truss like this. Let's see if I can draw that a little bit better, straight line. Simple 3-bar truss supported by some external reactions. Now, what am I looking at here? Again, this is a two-dimensional planar truss example. This is an example of one. So these little dots right here, those are the joints or the smooth pins, okay? Now, these linear members in between, those are your what we call truss members. Okay, so in this particular illustration, how many joints do we have? We have 3 joints. Even the support reactions are considered as joints. And we have 3 members, 1, 2, 3, or 3 bars. Okay, what would be another example of a truss? Well, you could have one that's a little bit more complicated. Let's see if we can draw straight lines again. So here you see we've got several members and several joints. And let's say it's supported by a pin and a roller. So here, how many joints do we have? Well, we'll just count them. 1, 2, 3, 4, 5, 6, 7, 8 joints. How many members do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think I counted that right. You can try to count them again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13 members. 13 members. So, yeah, so sometimes counting can be hard, right? So that's another example of a two-dimensional planar truss system. What about a 3D or space truss? So here, that would look, have all 3 directions engaged at the same time, X, Y, and Z. So you could see a simple situation, like this, where you have these multiple members, interconnected like this, and, maybe you've got an applied force at some angle here. Okay, so for the purposes of this background video, I'm going to focus more on talking about two-dimensional planar trusses, okay? Now, truss systems, the analysis of them, we see quite often in a statics course, sometimes in mechanics of materials. We definitely see it in a structural analysis course. And most of the time we focus on two-dimensional planar truss analysis, although it's not difficult to analyze a 3D space truss either, okay? But again, for the purposes of this background video, I'm going to focus more on 2D planar trusses. So let's talk about it a little bit more detailed, okay? Let's talk about the analysis assumptions. We got a few analysis assumptions here. I'm going to go through them one at a time. When we analyze a truss, what we're ultimately trying to do, you want to write this down, is determine member forces. So whenever you hear the term analyze a truss, what you're typically doing is finding how the applied forces are transferred through the truss members and then eventually make their way to the external reactions, okay? So in order to do that, we need to understand some underlying assumptions here. Let's look at number one here. The assumption number one is that applied loads are point forces that act directly at the joints or are transferred directly to the joints of a truss. So if we go back to our illustration here, you notice that I have these joints here. Where would the applied loads be assumed to act or be transferred to? They would be acting directly at joints somehow, okay? Notice that I'm not assuming applied loads are acting along the length of the member. That's a no-no. They're acting at the joints, okay? So that's assumption number one, okay? Now, if an applied load was acting along a member length, then that's not really going to be a truss anymore. That's going to be a beam or a frame, okay? But again, we're talking about truss action and truss behavior right now. So that's assumption number one. Assumption number two. Since members are connected by smooth pins, the center lines of the connected members are concurrent and each member is a two-force member. Remember, we talked about two-force members in another video. Member forces will lie along the longitudinal axis of the member, okay? So what does that mean for us? That means that when I look at an individual member of a truss like this, for example, let's say I extract a member of a truss. We're going to have forces that develop throughout the longitudinal direction of each member, okay? Now, those forces will either be compressive or tensile. So in this particular illustration that I just sketched, we have this member subjected to this compressive force C that's transferring through its longitudinal axis, okay? Can I have a tensile force? Absolutely. Let's say I've got another slender member, a truss member here. Okay, let me draw that a little bit better for us. Okay, so you could have the forces causing a tensile effect or pulling on the member along its longitudinal axis, and that would be a tensile effect. Now notice in both of these cases, we're claiming that truss members are two-force members. What does that mean? That means that the line of action of the force lies along the longitudinal axis of the member, okay? So that's what we call a two-force member. We sometimes call this an axially loaded member, okay? So we can even make that as a note here. This is AKA axially loaded member. All right. What other assumptions do we have? Well, the third assumption is that an entire planar truss, which is a 2D truss, is a two-dimensional rigid body, and we can apply three equilibrium equations to solve for support reactions. And if you remember, for 2D rigid bodies, what are those three equilibrium equations we can use to analyze a 2D rigid body? Sum of the forces in the x direction equals 0, sum of the forces in the y direction equals 0, and sum of the moments about some point O equals 0. And so again, looking back, excuse me, looking back at these planar trusses, you notice that they have supports here that look familiar, an external hinge or an external roller. So this whole thing in its entirety is a 2D rigid body that has these external support reactions that we can solve for, okay? So that's a analysis assumption number 3. What about analysis assumption number 4? Well, each truss joint is a 2D particle, and we can apply two equilibrium equations to solve for member forces. That's going to be some of the forces in the x direction equals 0 and some of the forces in the y direction equals 0. So again, if you want to zoom in on a particular joint, okay, you're going to have a joint is a particle, and a particle has two valid equilibrium equations, okay? Now, what's cool about this is all of these particles are interconnected by the members. So when we think about number 4 here, we've actually seen situations like this before. Think back to earlier in this context and in this playlist when we looked at a mass or a weight hanging from a cable system, okay? That analysis method that we used when analyzing forces in multiple cables in a cable system is basically this number 4, treating each connection point or each joint as a 2D particle, okay? Now, when we analyze trusses, there are two methods of analysis to determine member forces. So again, I'm going to make a note here, ... to determine member forces, okay? One method is called method of joints, and the other method is called method of sections. Now, we're going to have some later videos where we provide background information more specifically on each of these methods. But for this video, we just want to kind of provide an overview of what a truss is and its assumptions overall. Okay, so that concludes this video. I don't know if you could tell, but I've got a little bit of allergy problems right now, so I've got kind of a scratchy voice. Thank you for being patient with me and sticking with me to the end of this video. Please hit like and subscribe if you found this video helpful, and be on the lookout for other content like this. Thanks for watching.